So see, UVM config DB. Okay, config DB. What is the purpose we are using means to store the data and retrieve the data. And once we set the config DB, we can get the data in anywhere. Okay, so UVM config DB is set in UVM top. Okay, in the top we are setting means in the bottom, whatever the components we have, in the bottom we need to get the data. Okay, so that means retrieving the data. See, what is the use of this config DB? The config DB is a centralized hierarchical repository. Okay, they will ask you, okay, what is the difference between the UVM config DB and UVM resource DB? UVM resource DB, there is no hierarchical repository. Okay, so but config DB has UVM hierarchical repository. Okay, so based on that, we will get the data. Both config DB and resource DB both are used for getting the data and then storing the data and as well as retrieving the data. Okay, but in UVM config DB there is a hierarchical process is there, and resource DB there is no hierarchy. Okay, so both are same. See, and then it provides flexible way to pass the parameters. Okay, and setting as well as objects between the between the objects and components. Okay, and without hard coding dependencies. Okay, hard coding dependencies are not there. Hard coding means we are manually coded, okay, some data. We are manually giving some data to our variables. Okay, see that is the UVM config DB. So see UVM config DB. So instead of passing parameters through constructor or hierarchies, config DB offers that centralized configuration. So I told you that. So by using this config DB, we are setting the data. See, what is the traditional approach? So constructor we are using. Okay, in the constructor we need to hard to change whatever the data we have. That is hard to change the data, but it is flexible and decoupling is possible. Okay, whatever the data we need to set the data, so that will be flexible. Okay, so what is the syntax for this? UVM config DB int and set variable names. Okay, similarly UVM config DB integer and get the variables. Okay, so decoupling means components don't need any direct reference for each other. Okay, that is the decoupling. Okay, that means if you decouple one component, you can decouple it. Okay, other components don't know it. Okay, and then flexibility. Flexibility means we can set anywhere. Okay, so configuration can set from anywhere in the test or command line, anywhere we can set that. That's why it is a flexible. And then hierarchical path. So hierarchical path means, so whatever the top we are setting, in the below we are getting that. Suppose if we are setting config DB in the environment side, where we are getting the data? In the agent we will get, in the driver we will get, okay, in the monitor we will get. Okay, so depends upon the lower components, it will get the data. Okay, so type safe, that means parameterized type. Okay, whatever the data we are taking, so that will be parameterized. Why we are taking parameterized? If you change one variable, then entire data it will be changed. Okay, suppose my parameter is address width and depth. So width is 8-bit and depth is 16-bit I am taking. Now I want to change that, width is 16-bit and depth is 32-bit. Okay, so now I don't want to go in all the test cases where the data width and depth is there. I don't want to go there. Where the parameter we have used, at that parameter I will change, and then it will be applicable to everywhere. Okay, so that is the use of parameterized classes. Okay, so and then priority. Okay, overriding is easier. Okay, so just later setting overrides earlier ones. Okay, whatever the we are setting in the earlier ones component, we can override it. That will be possible. Okay, centralized, one place manage all the configurations. Okay, that is the config DB usage. See, this is the configuration DB concept. See, setting configuration, that is the producers, and getting the configuration from consumers. Okay, so in the producer side, we are setting the config DB and then getting the data at consumer side. Okay, so that is the use of configuration database. See, key points are type, path, field. Okay, so what is that values we have seen in our whatever the syntax. Okay, see, setting configuration, UVM config DB scope resolution set. Okay, in that set, what is the things we need to set? UVM component context. Okay, so context is usually we are taking this or null. Okay, this is used for current component only. Null is used for entire global operations. Okay, so see, UVM context is usually we are taking this or null, and then string instance name. Okay, what is your instance? If you are taking virtual instance, okay, some VF you are taking, that instance name you need to mention. Okay, so string instance name, so that is the string instance name. And string field name. Okay, what is your field name? So field is maybe either integer data type or some string data type. Okay, or any type. Okay, so that is your field. So configuration field name. And type value, you are setting some value. Okay, so then whatever the value you are setting, that will be stored in this string field name. Okay, string field name and string instance name. Okay, see, there is a type. Okay, what is the type? It may be integer type or string or object, virtual interface, whatever the type you are taking, all the data types you need to place here. Okay, so type is a data type, either integer or string or virtual interface, whatever it may be there. Okay, so you need to place here. Context. Okay, already I told you that UVM context, this means current component. Null for global. Okay, so globally entire all components we are setting that, that is the null. I told you instance name, that is the hierarchical path. Okay, so whatever the path we are setting, so we need to set that. Okay, and then field name, that means name of the parameter. Okay, configuration parameter, that we need to mention. And value, that means configuration value, whatever the value we are taking, that is the configuration value. See, I am setting the config db here, example for setting configuration. So in my test I am setting the configuration. Okay, so just I am setting the configuration set. What is the syntax for this? In UVM build phase, we are setting this configuration. Okay, so super dot build phase is there, and then see UVM config db, my type is integer type, scope resolution set. UVM component context, context is this. Okay, this you are using means, okay, so that is for this component only. And then star I am using, that means string instance. Okay, instance is nothing but path, I told you, right? So if you are mentioning the path, that means environment, inside the environment agent, inside the agent, so driver, and then monitor I am setting them. Okay, so that path you need to mention. If you don't know the path, means give the star. Okay, so it will set anywhere, that is the global representation. Okay, and then string field name, so field name is timeout. What is the timeout? I am giving the value 1000. Okay, so that is my setting the configuration for timeout. In this way, any data type you can set. Okay, so that is the UVM config DB setting. See, in the below set specific configuration for driver, you are setting for driver. Okay, see, I told you that. So this is for all components. Okay, this timeout is applicable for all components because I am setting globally. Okay, here UVM config DB, same integer data type I am using, and then scope resolution, after that setting, and then what is the path in environment, agent is there, and then driver I am setting there. Okay, this is the last component we are setting there. And then here I am putting the number of transactions. Okay, I am configuring the transactions should be 100. Okay, I am setting the value 100. Understood how I am setting the config db in the test side? Okay, see, set string configuration, how we are putting the string configurations. Okay, see, same, set test mode. In test mode we are setting the configuration, set config db string. Okay, string name may be any type of, okay, and then set this for this component, and star is for entire all components. And then your string instance name is, sorry, string name is test mode. Okay, in test mode we are setting the data type. So here debug we are mentioning, that means under the debug whatever the values we have, it will be setting, that means severity level we are setting there. Okay, so not giving the value directly, so severity level we have setting. And then see, set log file names. Log file names, where you are setting the log file. I want to see the log file in the environment and monitor side, so monitor.log. Okay, so this monitor.log is setting in the file name. Okay, log file name, I am getting the data in that anywhere. Okay, so this is the config db setting. Okay, so based on the string names I am setting the config db. Okay, so similarly, so string name, instance name, okay, for integer configuration, as well as string configuration, and then set configuration for objects. Okay, so what are the objects we have? Sequence items, sequence, and then transactions. Okay, config db. So all these are objects we are creating as. Okay, see, so just this is the configuration. It is derived from object. Object is my parent class, and config is a agent config is a extended class. Okay, so in that class registration is there, and then see, string mode is the normal mode, and then number of transaction I'm putting that 100, is active is equals to 1. Okay, after that constructor I'm closing my configuration. Okay, so then in test, whatever the build phase I'm taking, before that you need to consider the class registration, after that custom constructor, after that build phase. In the build phase, what I am doing that I am setting the config db. Okay, create configuration. Configuration. So just I am creating the memory for that. Okay, object creation. Whatever the configuration I am taking. See, well, this is my class name, right? Agent configuration. For that agent configuration, I am taking the handle. That is configuration. Okay, that means I am using the configuration in my test. Okay, whatever the class, whatever the properties represented in agent configuration, I am utilizing in my test. Okay, by extending the class. Okay, so then I am creating the handle, that is config db. So I am creating the memory. After that, see, number of configuration, number of transactions is equals to 50, and then config mode is debug. Okay, so my config mode is debug. So how we are setting the config mode? So this is my config mode, test mode, debug we have set, right? Same way we are setting the configuration here. Okay, set database, set in database. So config db hash your type, class type. Okay, so type is agent configuration, that is my class. Okay, so already I have taken the handle, that is configuration. So then my type is agent configuration. Okay, agent configuration set for this. Okay, this component I am setting for this test only, I am setting. Then environment agent, that is the uh, syntax. Okay, environment dot agent dot star. Okay, in agent whatever the components are there, it will be applicable for all. Okay, and then configuration, this is my string name. Okay, and then setting the value, that is the configuration value. That means I'm storing the value here. Okay, from configuration to configuration state. Okay, understood? In this way, any type of data type you are taking, suppose I'm taking int 31 down to 0 address. Okay, so you need to set the configuration DB for that. Okay, how we are setting that configuration DB? Config DB. So integer. Okay, so how we are setting that integer means, see, I will tell you. Hmm? Okay, fine. దీని తర్వాత కదా. So this is the user config DB. See, see how I am setting the user config DB. See, this is the user config DB set, right? Okay, so virtual interface I am setting the memory. Okay, whatever the virtual interface I am taking, see, memory interface I am taking, right? Okay, so user config DB virtual memory interface. For that, what is the handle I am taking? INTF, memory interface INTF I am taking. Okay, So that is the memory interface and IMTF is the handle. Okay, same way, what is the thing I'm saying that, so in some bit I'm taking, okay, bit some 31 down to 0 address I have given. Okay, so then how we are setting the UVM config DB here? Same way. How we are setting? Bit 31 down to 0 address I am setting the config DB. Okay, same UVM config DB. Okay, so hash it. Here, what is the data type here? Why I'm using bit, right? Bit 31 down to 0. Okay, this is the bit I'm setting that, and scope resolution set. In set, same way, null. Okay, or this you can use, and then string instance name, that is the star. Okay, here address I'm taking. Okay, string name is the address, same way address I'm mentioning. Okay, in this way we need to set. Okay, for not only single component, we can set all the components. They will ask you why you are setting config db for virtual interface. Okay, so just search in ChatGPT what is the giving. So my answer is, why I am setting for the virtual interface means whatever the data we are having, all the data we are setting into that virtual interface. So then, whatever the properties or data types we are having, right, in our test bench, okay, or design, okay, all the signals we are assigning to interface. Okay, so whatever the data types we are having, all the data types will be there in our interface as well as monitor, and then driver is also having. Okay, so from driver to DUT we are driving the signals, okay, through interface, virtual interface. So interface also having our signals, stimulus is having. That's why we are setting the config db to virtual interface. Okay, not for individual data types. Okay, understood? Similarly, get uh, get type using config db by using get type. We are retrieving the data. So where we are retrieving the data? See using config db type t and get using component context, comma string instance name, comma string field name, and reference key value. Okay, same thing. Same thing we are using that. Okay, so what is the data we are using? See, here I am setting the virtual interface, that is the handle is memory interface, and memvar is that my handle. Okay, so this is my interface name. Virtual interface is the keyword. Okay, so then my interface name is memory interface, and then handle is memory var virtual interface. Now I am getting the data from which one? So if not UVM config DB, that means you are not set getting the data, then I will get the fatal error. UVM fatal get full name, comma. So that is description. Virtual interface must be set for. Okay, you are setting the virtual interface. After that, what is the data we are getting? So where we are getting from the data? Memory interface, memory virtual interface. Okay, so that is the get method. Now I'm writing this is used for UVM component context. Okay, context is for this. Okay, this component. If you are writing null, okay, null means global. Okay, and then star is represent for global. Or if you mention some path like environment dot agent dot driver, okay, it is setting for driver. Okay, and then what is my interface name? Memory interface. How what we are setting, where we are getting the data from? Virtual interface. Okay, so that is the string reference t value. Okay, reference t value is the virtual memory virtual interface, memory virtual interface. అర్థమైందా? So this is how we are configuring, how we are using configuration database in our test bench, and how it is storing the data, and how we are getting the data. Okay, so this is one. And similarly, handshake mechanism between the sequencer, and driver. Okay, so how we are getting the data from the sequence and sequencer and then driver? See, so this is the sequence. In between the driver, sequencer is there. Okay. First, sequence item will send the request. Okay, send request to sequencer. Okay. So sequence item will send the request to sequencer. Any request from the driver. Okay, it is seeking the data. Who is seeking the data? Now I am ready to transfer the data. Okay, so just send the sequence. Okay, send the request to the sequencer. Next, driver will send the grant. Okay, data request from the driver. Okay, once driver is sending the request to the sequencer and sequence is also sending the request to the sequencer, then handshake mechanism is happened. Okay, now what is the third option? It will give that, okay, grant request to sequence send the request, then sequencer is granting that request. Okay, so now sequence will sending the items. Okay, so before sending the items, randomize the sequence items. Okay, it is randomizing the sequence item and send sequence item to sequencer. Okay, it will send the sequence items to sequencer. Then driver is getting the data. So how we are getting the data? Get next item through that the driver and sequencer handshake is happens. Okay, handshake mechanism is happens through get next item. Okay, through get next item, that is the fourth option. And then see, what is the fourth option? Randomizing the sequence, randomizing that. And then what I am saying. Okay, so this is the handshake mechanism in sequence, sequencer, and driver. Okay, first sequence will send the request to sequencer. Okay, after that driver will send the request to sequencer. Then handshake mechanism is happened. After that, sequencer will send the grant to sequence. Okay, so whatever the request is sent by the sequence, then sequencer will send the grant. Whenever driver is sending the request to sequencer, I need sequence items. Okay, so driver is sending the request to sequencer, I need sequence items. Then sequencer will send the grant. Okay, so grant request to sequence. Then after that, it will whatever that sequence is there, it will randomize the data. Once randomize the data, okay, then send the sequence item to sequencer. Okay, it will send the sequence items to sequencer. Okay, after that, then sequencer will receive the sequence item from the sequence. Then driver getting the data. Okay, send sequence item to driver. So sixth step is, so through TLM ports we are sending the data to driver. Okay, then so DUT will respond to that. Whatever the signals, whatever the sequence items sending from the sequencer to driver. Okay, so then driver will send to the DUT. Then DUT will respond to that. Okay, so DUT will respond that. DUT responds via driver to sequencer. Okay, So that is called item done. Okay, so item done, and then so item done signals to sequence. That is the response, waiting for the response. Understood? This is the handshake mechanism between the sequencer, and driver. Okay, first sequence will send the request to sequencer. After that, driver is sending the request to sequencer. Okay, sequencer will grant the request. Okay, after that, sequence will randomize the sequences. Okay, so we'll randomize the sequence items. After that, it will send the sequence items through sequencer. Okay, so then driver will receive that. Okay, send sequence items to sequencer. Whatever the send sequence items to, then send sequence items to driver through TLM ports. Okay, through TLM ports it will receive the sequence items. Okay, then driver is sending the sequence items to DUT. Okay, DUT will respond via driver. Okay, so once sending the sequence items to driver, okay, so then driver is sending the sequence item to DUT. DUT will respond according to that. Then item done will be the response from the DUT. Okay, so then get item done signal to that sequence. So once all the sequence items sending from the sequence to sequencer and sequencer to drivers, driver to DUT. So then if it is done, then it will stop the handshake mechanism. Clear? So then there is a two steps in between the driver and sequencer, that is the get next item, item done. Okay, so these are the two handshake mechanism in between the driver and sequencer. Okay, understood? So next, so this is the config DB setting, and also we are getting the data, right? See, same way, getting configuration DB. So that is the syntax. So config DB type get component context. Okay, so component context is the type getting the context, and then see string instance name, that means instance name. So usually what we are taking empty brackets. Okay, double quotations with empty. Empty means global. Okay, and then string field name, that is the configuration field name, and then inout type value, that means whatever the data we are receiving, that we need to mention here. Okay, so variable to receive the value, where we are receiving the values. Okay, we are setting the variable right in config DB. That variable name we need to mention here. Okay, see. So type is a data type. Most of the types we are using. Okay, context is the usually this we are using. This means this component. Okay, and instance name. So instance name usually when we are calling the component. Okay, so by using empty string. Okay, so usually we are using empty string for the string name. Otherwise we are calling the some name. Okay, and then field name, name of the configuration parameter. So must be match. So must match set value. Okay, whatever the set variable we are taking, that is the field name, and value must be variable to receive the configuration value. Okay, whatever the configuration value we are setting that, so that variable we need to mention here. Okay, see, in driver we are getting the data. So where we are configuration DB in build phase, if you are not using config DB int get, this is the this component, and then empty space is the string instance name. Okay, and then timeout value, we are getting the timeout variable. Same variable we are also mentioning here. Okay, same timeout we are setting in our um, what is that, same timeout we are mentioning in our set configuration. Okay, same type I am mentioning here. If it is not true, then I am getting the warning message config db using default timeout value. So whatever the timeout value usually mentioned, that timeout value we are mentioned here. Okay, So this is the configuration DB. So to try to get the timeout from the config DB, okay, we are getting the timeout from config DB set value. Same way, so get number of transactions. Whatever the number of transactions we are putting in our set configuration DB, right? Okay, same configuration we are getting that. See, if not using config DB, int is a integer data type, okay, and then get, this is the component, and null is a empty space for global, and number of transactions we are setting in our set of configuration. Okay, so from number of transaction to number of transaction, I am getting that. Okay, from this string to this string, I am getting the data. Okay, in setting data, wherever the left hand data value we are taking, that is setting into that string field name. Okay, that string field name we are placing here and then getting the data from the string field name. Okay, understood how I am getting the data and how I am setting the data in configuration. Same way strings I am using, log file and log file, same data type. Okay, and similarly test mode and test mode. Okay, and objects also we are setting that configuration DB. See config DB. So even config DB, agent config DB, same config. Okay, same name I am using without any confusion. We are using the same name. Okay, see, this is the hierarchical path. UVM top. Okay, in that environment, agent, driver, monitor, sequencer. Similarly, agent one. Similarly, I am getting the test, environment side, and agent instances. Okay, this is the hierarchical path we are mentioning. Okay, if you set on the top, you will get on the environment as well as agent, as well as driver, monitor, and sequencer. Okay, similarly, we need to mention the instances for that. Environment dot agent dot driver. That means only agent zero drivers only we are getting the data. Okay, that is the path we are mentioning. And then environment dot star dot driver. That means environment all agents in one driver. Okay, so all agents drivers, and then everything in agent 0, environment dot agent dot star. That means in agent all components, so all components in agent. Okay, so all components, that is star. Okay, globally we are representing all agents. That means environment dot agent dot star. Okay, so agent star, we can, all agents we can call it as agent 0, agent 1, agent 2, all the agents. Understood how we are setting the data path? So if you mention star means global, no need. No need to mention any component. If you are not mentioning star means, then you need to set the path. Which path I want to store the data. Okay, so that is the path I am mentioning here. See, star is for everything at everything at that level. Okay, so that means matches all. Environment dot star, that means all direct children of the environment. Okay, so then agent 0, agent 1, scoreboard, all these things. Okay, if you set for all environment, it will get all the data. Okay, in agent environment, in agent 0, agent 1, and scoreboard coverage, all these things, I'm getting the data. Okay, environment dot agent star, that means matching all agents. That means agent 0, agent 1, agent 2, etc. Okay, and star dot drv, that means all the components named as driver. Okay, so any driver anywhere. Okay, any driver we are getting the data. And then environment dot star dot drv, that means all agents, all drivers. Okay, so agent dot driver, agent 1 dot driver, all the agents, whatever the drivers we have, so it will be set. Okay, so this is the hierarchical configuration. So clear, this is all agents, environment dot agent dot star, that we are setting the data. And then so configuration set. So using config db set this environment dot agent 0, and then some priority we are mentioning that. Okay, 100 and 50, some priority based we are setting that. Okay, so and then all drivers. Okay, specific agent and priority data we are setting, and then all drivers we are setting. So that means dot star dot driver drv. Okay, star dot drv means we are setting all the data, and then fast mode, and then so mode is fast. Okay, we are setting the data. And similarly, specific driver. Specific driver means environment dot agent zero dot driver. In agent zero, we are setting the data in the driver side. Okay, that is the slow mode we are setting. Okay, so this is the configuration and override. Okay, so how we are configuration priority and overriding is happening. Okay, so globally we are setting the value, and environment dot value we are environment level, and all agent levels, and all specific agent level, and then drivers level, specific drivers level. Okay, same way virtual interface we are setting that. Okay, one of the most common uses in passing virtual interface to components. Okay, all components we are passing the virtual interface, right? Okay, same way. So in top we are setting that, on the top we are setting the interface. Okay, after that interface talk, and then clock signal representation, dut instantiation, and initial begin. In that I am setting the config db. Config db virtual bus interface, and set null comma, that is the bus interface, that is the bus virtual interface, and my handle is bus. Okay, so that bus I'm mentioning. So now the virtual interface I'm setting the config db. Same this virtual, how we are getting the data, tell me. If not UVM config DB, so virtual bus interface get null comma, and then some path we need to mention, and then bus comma bus. Okay, so that is the interface handle we are getting. See, just I am getting the data. See, this is my config DB getting the data. This and empty space bus virtual interface bus VAF, and then VAF. Okay, sometimes we can also take bus VAF. Okay, so this is the setting data. This data is setting into this value. Okay, bus interface. Now I am getting the data bus VAF to VAF. Okay, this is setting and getting the data in our components. In driver I am getting the data. Okay, and also object pattern, same way config db agent, that is the object pattern we are getting the data, right? Okay, so same thing I'm getting the data in the object type. Okay, so and then create the memory, where we are config db setting, this is the creating the memory, and then environment side. Okay, so this is all about UVM config db. What happened? So configuration timing. So phases build to connect, and collaboration and run phase. We are getting the data in build phase. Okay, and config DB. So use config DB in connect phase. So we are getting the data, right? So timing correct. So we are setting the data in timing. So this is the setting data given config db time mode 1000. Okay, same way we need to get the data, right? So what is the correct data we are getting? See, uvm config db get this comma time mode. Okay, this is the correct way to get the data. Incorrect way, say driver time mode 1000, this is the setting the data. Okay, and then getting the data, this is the getting the data, but wrong in the connect interface. In connect phase we are getting the data, that is not possible. Okay, so then we need to get the data in build phase only. Okay, connect phase we don't get the data. See, so set after build phase. What is that set after build phase? In the build phase we are, see, this is the creating the memory, right? This creating the memory we need to set after the build phase. Okay, after the configuration we need to create that. That is the wrong. I told you yesterday, right? Instance also we are using config db creation. After the instance only we need to create the memory. Okay, so same thing. These are the command lines. Same complete configuration code. Set this code. Okay. So where we are setting the data and then getting the data. Okay, all these things are mentioned here. Just check this code. Okay. So this is the mistakes we are doing. Getting configuration too late. Okay, so that means we are mentioning the data. So config db get this comma empty space timeout comma timeout. Okay, so it is getting data too late. Where we need to get the data? So function void build phase super dot build phase and then void data. So tick void config db int get this comma empty space timeout comma timeout. What is the difference you find here? So you are getting the data in connect phase. So I don't want to get the data in connect phase. In build phase only I want to get the data. That's why it is in build phase only we are setting the data and then getting the data. Okay, don't go for the connect phase. That is the correct one. Okay, see wrong instance name in get. Okay, so what we are using? Function void build phase super dot get this comma environment dot driver timeout comma timeout. Okay, so this is the some field name we are mentioning. Here we need to mention empty space. Okay, so empty space we need to declare. So empty string means, okay, that is me. Okay, so empty string means me. Whatever that data we are setting the data, that only we are getting the data. Okay, so that is me representation. If you mentioned any path means it will get that some error. Okay, that is the wrong instance name. And then type mismatch. Type mismatch means you are setting the data in integer type and then getting the data by string. So it is not possible. Okay, you need to get the data integer data type only. Okay, so that is the other thing. And then setting after building. Okay, see creation we need to build phase only we are setting, but it is too late. Okay, so environment is already built in. Okay, this is already built in. After that we are setting the data. That is wrong. Okay, after the creation of after the setting the data, then only we need to create. Okay, this is the thing I told you already. Okay, so in build phase you need to configure the data. After that only we need to create the data. Okay, so that is the correct one. So this is the quick reference how we are setting the data. So this is for usually for this context, and empty space is for instance name. Okay, so usually empty string only we are using, and field name, that is the parameter name. Value means whatever the receiving value. Okay, and then common types: set, set. So virtual interface, config db, bit, string, integer, whatever the data types we are having, all the data types we are getting. These are the wildcards, like all components, environment dot star, that means all child classes, that means children of environment, and then environment dot agent, all these things. Okay, understood? Even config db. See, what is the things here mentioned? Create transaction, start items. That means uh, request grant. Okay, request grant. Okay, start item of request. Okay, in this way we are sending the items to driver. Okay, and then third one, get next item. Get next item. It is from driver. Okay, so driver is sending the get next item. Then it is granted that randomize the transactions. Okay, so after randomization, finish the items. Okay, that means send the transaction to driver. Okay, So that is the forward transactions. And then driver transaction to DUT. Driver is sending the transaction to DUT, then driver is sending that item done, then done, next generation. Okay, next transaction it will be going on. Understood? So this is the basic transaction handshake mechanism. So first I need to create that. How we are creating the item? Some transaction handle equal to class name, and then scope resolution type ID create, scope resolution create, and then class handle. After that, what I am sending? Start item of request, or send items of request. After that, randomization. After that, finish item. So that is the basic mechanism or basic handshaking between the sequence and sequencer and then driver. Okay, in the driver side, what is the handshake mechanism? Sequence item port dot get next item. Okay, get next item, and then driver transactions. After that, sequence item port dot item done. Okay, so that is the handshake mechanism. Understood? See, so this is the standard handshake, start item or finish item. Okay, so in this, what is the syntax for this? Okay, see, my transaction is my class name, then handle is request. Okay, so then request equal to your class name, my transaction type ID create. Okay, start item. What is the start item replacement here? Start item means sending the request to sequencer, and then request from the driver to sequencer, and then grant from the sequencer. Okay, sending request and grant request, these two are replaced by what? Start item. Okay, after that, randomization. Okay, after receiving the request from the sequencer, and then so after receiving the grant from the sequencer, then it will randomize the items, that is the randomize the items. And then finish item, what is the replacement of finish item? Sending transaction to driver, after that item done. Okay, these two are replaced by finish item. Okay, understood? Start item, randomization, finish item. These three are handshake mechanism. Before that, we need to create the item. Okay, this is the handshake mechanism. Okay, standard mechanism. See, start item. What is the start item do? Re request, and then some set priority, and then so sequencer base sequence equal to null. Okay, this is the task item do. What is that? What does send grant request to sequencer? That is one item. After that, blocks until the driver calls the next item, and then returns when driver is ready. That is the start item doing. You need to say that. Okay, so start item, what it is doing means sequence will sending the request to the sequencer, and then driver is sending the I need get next item, and then driver is receiving that, driver returns that I'm ready. Okay, so returns when driver is ready. That is the sequencer to sequence, there is a grant. Okay, so this operation is done by start item. All these three are replaced by start item. Okay, so then finish item, what is that? Task finish item request, and then set priority, some value we need to mention. What it does? Send transaction to driver. That is the send transaction. Before that randomization we need to do that. Okay, after the randomization we are sending the transaction to sequence driver. Okay, so then blocks until driver calls that item done. Up to what extent we need to send the sequence items? Driver will send that item done. Okay, so then returns when driver completes the transaction. That is the finish item. Okay, so these three items we need to do it. Okay, the driver side, what is that? Get next item and item done. Okay, so receives and acknowledges the transactions. That means see sequence item port dot get next item of request. Okay, that is the get transactions. Okay, so blocks if none ready. Okay, no one is ready means it will block the transactions. If it is ready means then driver will do the some transactions. Okay, driver is setting some transaction. After that, driver will send the item done, sequence item code dot item done. Understood? So this is the handshake mechanism. Get next item, that is the request transaction. So task get next item, that means output of request. Okay, what it does, grant the permission to wait sequences and blocks until sequence calls finish item and returns with randomized transaction. Okay, these three items it will be doing that. What is that item done it is doing? Item done it is doing that signal sequences that transactions is complete, unblock that sequence item finish, optionally will provide the response transaction. So response transaction is an optional. Okay, get response is an optional for that. Okay, this is the complete handshake mechanism. So this is my sequence item. From that I am extending my class, my transaction. Based on that I am mentioning some data types. After that, in sequence, what we are representing in task body, we are creating the handle for that. Okay, transaction. After that, step 1, create the transactions. Okay, in the step 2, request grant, that means wait for driver to ready. What, how we are sending, send items, right? Sorry, start item of request. Okay, whatever the request we have created, then that we are starting. Okay, start item of request. So if we are getting the data, then I am getting the got the grant from the driver, and then high, I am representing the information messages. Same way, step 3, randomize it. Asset request dot randomize. Okay, so if you are mentioning some inline constraints, you can mention, otherwise no problem. Okay, after that, fourth step, send to driver. How we are send to that driver? Wait for driver to complete, and then item done will send. Then I am finishing the items. This is what I am explaining in the sequence. Okay, same way, driver handshake mechanism. What is the driver handshake mechanism here? Step 1. So grant get next items. Okay, get next transaction. That means grant the permission and waits for that. Sequence item code dot get next item of request. Okay. After that, we mention some display statement, and then driver to bus some request is there. So that means driver transaction to do pass the transaction to DUT. After that, completion, signal completion. That means unblock the sequences. Okay. So then next generation, next transaction will be initiating. After that, sequence item code dot item done. If we see that this handshake, then it will continue to next generation, next transaction generation. Understood? See, this is the driver transaction. See, virtual interface dot address, data, transaction dot data, write data. So transaction dot write data, VF dot value. Okay. See, create transaction, that means start. After that, driver from next get next item, that is blocked. After that, granted, randomize it, and the finish item receives the transactions and drives to DUT. DUT is active and crossing is done. After that, done is there, and then item done is there, unblock that. Okay, up to that blocking, after that unblock, then next transaction is doing. Clear? Will you explain that handshake mechanism? Okay, so non-blocking handshaking, that means try next item, and then what is that? So next item we are getting right, that is try next item, that is non-blocking. Okay, without blocking that, we will get the requests. Okay, same thing we need to do it here. So after that, item done, handshake with item done. Okay, so this is the item done. So get next item, item done. Some put ports we need to get the data. Okay, we need to put the data. See, sequence item port dot item done, and then we are putting the data. So some put get response from the data, and then sequence item port dot response. Okay, put response. So put response, and then peak also. So peak, no need to bother about it. Okay, just getting the data as well as copy paste method. Okay, Understood what is the handshake mechanism? So just check all these things. Okay.